So, dear students, today we are going to discuss about terrestrial telescope. So, terrestrial telescope. In the previous video, we have discussed about astronomical telescope. Astronomical telescope are used to view distant object, stars and planets. But the terrestrial telescope is used to view trees, buildings, and buses running on the road, and it is used for military operation. Means the military men or army personnel use it to view their enemy position. So main thing is that what is the difference between the terrestrial telescope and astronomical telescope? 90% it is same, but the drawback of astronomical telescope is that it gives a inverted image. Okay, so in order to rectify the difficulty or to remove the difficulty, a convex lens, thus this one, is introduced between the objective. Here this one is the objective and the eyepiece, having the focal length f, which is having the focal length f, the lens that is introduced to remove the difficulty, right? And it is placed in such a way that it is a distance of 2f from the eyepiece. So in order to rectify the difficulty involved in the astronomical telescope, we have used the lens having focal length f in the terrestrial telescope. Now we will derive the expression for magnifying power one by one. So angle beta, this one is the angle beta and this is the alpha, right? So we will use these things to derive the magnifying power, as alpha is equal to p dash q dash by f naught. This one is f naught and this one is the p dash and q dash. This one is alpha, and beta is equal to p dash q dash by ue, right? So we will proceed. So we have got alpha and beta, alpha and beta. So magnifying power is equal to mod of beta by mod of alpha. This beta and alpha are 10 beta and 10 alpha, right? So repeat, 10 beta by 10 alpha. So p dash q dash by ue into f naught by p dash q dash, as we can cancel it, so the result is f naught by ue, right? So now we need the ue. So in order to get the ue, we have to use the lens formula, that is 1 by v minus 1 by u is equal to 1 by f. So for the eyepiece, b is equal to minus d and u is equal to minus ue, right? And these things we have already calculated in our previous video. So that is equal to 1 by d minus of minus ue is equal to 1 by fe, that is equal to 1 by d plus 1 by ue is equal to 1 by fe, that is equal to 1 by ue. Now we can find this ue from here, is equal to 1 by d 1 by fe plus 1 by d. 1 by ue is equal to, we can take 1 by fe common, so 1 plus fe by d. So from this expression we can write m is equal to f naught by ue so that is equal to ue is equal to okay, right. So ue is equal to f naught by fe 1 plus fe by d. This is the desired expression for m. So m is equal to, you can write f naught by fe 1 plus fe by d. Yes. So the main difference is that we have three lenses here, lens 1, lens 2 and lens 3. So the length is modified. The length of the terrestrial telescope is more as compared to astronomical telescope. So this one is MD, right? MD, and M infinity is equal to f naught by fe, f naught by fe, as ue is equal to fe for relaxed eye. So L infinite is equal to the incremented length of terrestrial telescope as compared to astronomical telescope by 4f. So by the introduction of the lens we have 4f incrementation of length in case of terrestrial telescope. So LD is equal to, here we can write ue is equal to dfe by d plus fe. From here we can conclude du is equal to dfe by d plus fe. So ld is equal to f naught plus 4f plus dfe by d plus fe. So we have already concluded or find the result L infinity and LD. This is the length at a relaxed eye condition, and this is the length of the terrestrial telescope when the image found at D. Image found at D. D means the minimum distance of distinct vision. D minimum distance of distinct vision. For normal eye it is 25 centimeter. Okay, so we have find the result in both the cases when length for relaxed eye condition and length for image found at D, right? Thank you.